acids, bases, and salts. So, of course, we start with acids. Now, acids are substances that contain hydrogen ions that can be replaced by metal ions to form a salt. For example, hydrochloric acid with the formula HCl. It contains hydrogen plus ion right here, and we can replace this with metal ions such as sodium to form sodium chloride, or potassium, or any metal more active than hydrogen for that matter, to form all types of salts. Now, an acid can also be described as a proton donor due to the fact that a hydrogen ion is itself a proton. Since a hydrogen atom only has a one proton and one electron, when it gives up that one electron to form the hydrogen ion, it's basically just a proton by itself. So acids can be described as proton donors in a reaction. Now there are a few unique properties. They have a sour taste, and this is why most juices taste sour, because most juices contain citric or tartaric acid. They're highly corrosive. They have a pH of less than 7 on the pH scale, and they can conduct electricity when in solution, and they are known as electrolytes. Now, acids can undergo several types of reactions, and the first one we'll have is an acid plus a reactive metal. So let's use, for example, sulfuric acid H2SO4 plus reactive metal, let's say potassium. Potassium is a very reactive metal in group 1 of the periodic table. So what will happen here is that the potassium will replace the hydrogen since it's much more reactive, and it will form potassium sulfate plus hydrogen gas. So basically, acid reacting with a reactive metal, or basically any metal higher than it on the reaction table, will produce a salt of that metal along with hydrogen gas. Alright, now on to the next reaction. Acid plus a base. Now we'll get to exactly what a base is soon enough, but what you should know is that an acid plus a base will always give you a salt and a water. So let's use, for example, HCl plus sodium hydroxide, which is a base, and it will give you sodium chloride salt plus H2O. So acid plus a base will always give you a salt and a water. Now after this, now we'll do acid plus hydrogen plus metal hydrogen carbonate, as well as acid plus metal carbonate. Now both of them will actually give you the same thing. An acid, let's say for example nitric acid, HNO3, plus a metal carbonate such as sodium carbonate, what this will produce is a salt, hydrogen, and water. Now of course the sodium can replace the hydrogen ions, and so the salt that will be produced will be sodium nitrate. NaNO3 plus carbon dioxide plus H2O. Now, if this was a metal hydrogen carbonate, such as NaHCO3 sodium hydrogen carbonate, it would actually produce the same thing. So metal hydrogen carbonates and hydrogen carbonates react with acids in the same way. Now, there are several ways in which we can actually classify acids. The first one is in terms of strength. So, say we have the pH scale, and this is gonna be the pH scale for below 7. So we're gonna have 0 at 1, 1, 2, 3, 4, 5, and 6. This is for below 7, and the lower you get on the pH scale, the stronger the acid. So from about 1 through 2, or 0 through 2, that is, your very strong acid. At about 3 and 4, you'd have medium strength acid, and 5 through 6.9, you would have weak acids. Now, whether or not an acid is weak depends primarily on its ability to dissociate hydrogen. So there are some acids which give up some of their hydrogen ions in solution, and there are others which would give up all of it. So for example, hydrogen chloride or hydrochloric acid will give up all of its hydrogen ions in a solution to form H plus Cl minus ions, aqueous of course. And so it's a strong acid. But then you would have some weak acids such as ethanoic acid, CH3, COOH, which only give up some of its ions to form H plus ethanoate ions, and so the reaction is actually reversible with weak acids. Now, other than its strength, acids can also be classified in terms of their basicity. Now, the basicity of an acid depends on how many hydrogen ions are there per acid molecule or per acid formula unit. So, a monobasic acid will have only one hydrogen per acid molecule, and an example of this is of course HNO3. Then of course you have dibasic acids. An example of that would be H2SO4, and then you have tribasic acids like H3PO4. Now the final method of classification of acids is mineral or organic. Now the organic acids are also called alkanoic acids, as you might remember from my video on organic chemistry. So you'll have the organic acids and these are primarily carbon-based compounds, with many of which contain either one or more of the COOH group. And a prime example here is CH3COOH, and then you'll have mineral acids. Now these aren't primarily carbon based and they won't contain the functional group. For these ones, you'll mostly just see a polyatomic ion joined to a hydrogen ion, such as H2CO3 carbonic acid, or HCl. And another example of organic acid here is tartaric acid, acid found in grapes and pineapples. And you also have lactic acid, and you have citric acid. And the acids found, the organic acids are called such because they are typically found in living organic systems, while mineral acids, most of them are found in minerals or in nature. Now, there are actually some mineral acids in the body. For example, HCl is present in gastric acid in order to help break down foods. Now, let's talk about acid anhydrides. Those are substances which can react with water to form an acid. So, for example, carbon dioxide plus H2O will actually give you carbonic acid. And if you react sulfur dioxide with water, you will get sulfuric acid. Sulfur trioxide with water, you will get sulfuric acid. And if you react nitrogen dioxide with water, you get a mixture of nitrous and nitric acid. Now let's move on to bases. Now bases are the opposite of acids. They produce hydroxide ions when in solution. However, it's better to call bases a proton acceptor because not all bases will dissolve. And there's a specific name for the ones that do, and they're called alkalis. So alkalis are bases which dissolve in water and form hydroxide ions such as potassium hydroxide or ammonium hydroxide, but not all bases dissolve. Just like acids, bases have certain unique properties. They're bitter in taste, they're also corrosive, their pH is higher than 7, and they feel soapy, as well as they conduct electric current when in solution. Now, like acids, bases can undergo certain specific reaction. We've already talked about the reaction between a base and an acid. Another important reaction of a base is a base plus an ammonium salt. So let's say, for example, we have magnesium hydroxide plus ammonium hydroxide plus ammonium chloride. That's NH4Cl. Here now, what this will produce is a salt plus ammonia plus water. So you can go ahead and write in the ammonia plus water, and then finally we will obtain a salt, which in this case will be MgCl. Now, just like how you had strong acids and weak acids, you also have strong bases and weak bases. Many of the strong bases are actually alkalis, the one that can dissolve, and as the strength of a base is categorized by how well it dissolves its hydroxide ions in water. So if it only gives some of the hydroxide ions, it's weak, and if it gives basically all of them, then it's considered a strong base. Again, we also have basic oxides, which are the opposite of acid anhydrides or acidic oxides, and those can react with water to form bases. So, for example, example of a basic oxide will be calcium oxide, which can which could react with water to form calcium hydroxide, which is somewhat strong base, not very strong, but somewhat strong. Now that pretty much covers bases. Now to move on to salts. Now a salt is a substance formed when from the replacement of the hydrogen ion in an acid with a metal ion. Now I've talked about this before. We could replace the sodium in hydrochloric acid to form NaCl. We could replace the hydrogen in sulfuric acid with magnesium to form magnesium sulfate. But there are two different kinds of salts that you need to know about, and these are called normal salts and acid salts. Now a normal salt occurs when all of the hydrogen ions in an acid have been replaced by the metal ion. So for example, here we have potassium sulfate. This is a normal salt. Now an acid salt occurs when only some of the hydrogen ions have been replaced and some are left. So here we have potassium hydrogen sulfate, and this should be an example of acid salt, as well as most metal hydrogen carbonates would also be acid salts, and so on and so forth. You could also have a salt by the replacement of the hydrogen ion with not only a metal ion but also with an ammonium ion. So for example, we could have ammonium chloride. This of course would be a salt. And that pretty much covers acid, bases, and salts. See you next time.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.